Haha. Okay. So, what is the constant rate of change? I'm not asking for a number. What is it? That's how you compute it. Relative size of the change of y with respect to the change in x. Hopefully you said that. What is it in this case? What is the relative size of changes in y to changes in x? 2, okay? It's 2. What's the most, here we go. So we've been hammering this for a couple weeks now. What's the most important mathematical result of this? 30 seconds, go. Who can get it? Everyone should get it. I'm giving you a hint. That'll be really loud in the video. So if the relative size of the change in y to the change in x is 2, what is this incredibly important result that we've been talking about for the last 2 weeks? I know you know. Yeah? Okay, y changes twice as fast as x. That we didn't emphasize that as much, but that's absolutely true. No, what have we been hammering for the last 2 weeks? No.
The rate of change of x is 2 times as the rate of change of y.
Other way around. Other way around. You had it. This is the big thing that we've been talking about over and over and over again. Given any change in x, the corresponding change in y is 2 times as large as that change in x, or delta y equals 2 delta x. Okay? If that hasn't sunk in yet, today's the day. Now is the moment. Okay? That's what that means. That's what a relative size of the change in y to change in x of 2 means. That any change in x would result in a change in y of 2 times that change in x. Okay, so here is a different graph that's showing the same constant rate of change of 2. So instead of the y-axis being the quantity, now the y-axis is a measure of the constant rate of, or the rate of change. And so if that rate of change is always 2, it graphs as a horizontal line. So no matter what your x value is, the constant rate of change is 2. So do you see that these two graphs are both showing a constant rate, the same constant rate over every interval of delta x, the same constant rate over every interval of length x, delta x. Okay? So this is a new way. This graph on the left is kind of a new version of this one on the right in terms of showing a constant rate of change. The y values on that one are rate of change. And so constant rate of change would mean always, in this case, 2. So can you come up, so if this is the rate of change function, can you sketch what the quantity function would be that has this rate of change function? See if you can do it. So the y values on the graph that you're seeing are rate of change. What quantity function would match up with a function that has that rate of change function? Take a second, see if you can sketch it. Okay. So when x is less than 0, we get a rate of change of -1. What does that mean? A rate of change of -1 means for any change in x, y decreases how much? Y equals -1. Is that what that means? For any change in x, y equals -1. Is that right? No. For any change in x, y decreases by the same amount as delta x, right? 1 to be -1 times the change in x would be change in y. So for change in x, you're going to get the same amount decrease in y. That's what, right? What will that look like? Draw it with your finger. And then a rate of change of 1. You get a change at x, that means y changes how? Goes up the same amount, right? It's 1 times, delta y would be 1 times delta x. Therefore, delta y equals delta x. Draw it with your finger. Every change in y is -1 times the change in x. Every change in y is +1 times the change in x. Observations, comments? Yes?
What would the piecewise function have to be if it went in the third quadrant?
What's that?
If this slope was like negative and it went down in the third quadrant, like
So you're saying that the piece on the left was just lower?
no. The piece on the right was.
Oh, the piece on the right was just lower. Could the piece on the right just be lower? Would it still have a rate of change of 1 if we just moved it down? Yeah. This is just one of many possibilities. What about this? Does that have that rate of change profile? Still does. Do you see? What about this one? So given the rate of change function, it doesn't determine a unique quantity function. It only tells us what the rate of change is. So you get many possibilities. But if you thought of this one, that's great, okay? That's a great first step. But just know that we can take either of those pieces and move them down or up as much as we want, and the rate of change isn't different. Okay, so you've been reading about this. What's the basis of value? So you come with your income, and you look in the right row, and if you're single, and you get your tax that you owe, right? So come in here, I made 26. I'm a part-time worker. I made 26,500, so I'm going to be in this row right here. I'm single, therefore I'm going to pay this much tax. What's the basis for that value? You've been studying this hard. What's the basis for that value that it computes for the amount of tax that you owe? Is it a straight percentage of the 26,500 that I made? Just a percentage of that number? Yeah, so right, it's what's called you should think, no, it's not just a straight percentage. It's broken up into brackets, and it's what's called a progressive tax. Progressive tax, that you owe different percents on different dollars that you make, right? So as you make more money, your tax rate changes, okay? And so this is what we call a progressive tax. And that's what we have in the United States, okay? So here's this tax rate function. What is the input into this function? Income. And the output is? Tax rate. So if it's a rate, if this is a rate of change, go ahead. This is the output is the amount of taxes you pay. Oh, wouldn't that be great? I made $35,000, and this year I owe 33 cents. Yes. So not quite, right? What function is this? Okay, so this is the rate. So this is a rate of change, okay? And in fact, it's a constant rate of change. Therefore, what kind of thing is it? What kind of thing is it if it's a constant rate of change? It's a constant rates of change are, in essence, they are relative size. So it's the relative size of what compared to what?
Tax rate compared to
Okay, so right, it's the change in y or the change in x, of course. But in terms of this situation, it's the relative size of, so 0.33, like 1/3. What is 1/3 of what? What is 1/3 of what? Yeah, Jeff. Tax due. Right, it's the relative size of the tax due to tax income, right? Or the change in those things, right? A change is the relative size of a change in the amount of tax due relative to the change in your income.
Is it a rate, not due?
What's that?
Is it a tax rate, not tax due?
No, that is the rate. 0.33 is the rate. And so that's the relative size of how much you owe for the next little amount that you make. The relative size of how much you owe for the next little amount that you make. It's always, in this bracket, it's 1/3. Okay, so if we're making, here we are making, what, 35,000, say, in this bracket? So do we pay 33% on all 35,000? No. So the 33%, if I made $35,000, then that 33% is for which amount of money is it referring to? Okay, so the way that we want to think about this is, so yes, we owe 33,000 for everything greater than, wow, 6 figures. Sorry. So what did I mean? I meant 300,000. Sorry. Okay, so here we are, we're making 300,000. All right. So yes, it is 33% on everything greater than 171,000 up to 300,000. But in this function, it's really, we want to think of it as the tax rate on the next dollar that you're going to earn, or on the current dollar that you're earning. Okay, so if we're making 300,000, so the amount that we owe, that 33, if x is 300,000, we think of that 0.33 as the rate on this current dollar at 300,000. Okay? Okay, and so we got this, then you looked at this. What are the input and output quantities of this function? What's the input? Taxable income, amount earned, right? Taxable income. What's the structure of this function, and what's the form of each line? So the structure of this function is what we've been working on, right? Piecewise, right? It's piecewise. That's how the progressive tax rate then kind of comes out as a function. It comes out as a piecewise function, and the form of each line is point slope. This familiar slope that we learned last week, or earlier this week. So you got to recognize that every piece of this piecewise function is our point slope linear form, or linear form. Okay, so I want you to take a minute or two and decipher. I'm looking at line 3 there, starting with 0.25. What's the meaning of each of the following values from line 3? Go. In terms of the tax situation, so in context. In context. Write them down if you have it. Write them down. Practice writing them down. This is like a practice quiz. I'm going to reveal the possible correct answers, and you see how you did. Okay, so write them down. You can keep talking. So let me add to the task. So not only describe them in terms of the task situation, but just strictly in terms of X and Y. How about just strictly in terms of X and Y? How would you define them, or what would they be symbolically with X and Y? Okay, here we go. First one. This is the number of dollars earned above $34,000. Or you could say number of dollars earned in the 25% tax bracket. How'd you do? And what is this in terms of X or Y? Delta X, change in X. The delta X, the change in X. Okay, 0.25.
That's the tax rate.
Right. This is the tax rate for this bracket, which is the relative size of the change in tax to the change in income. So for any change in income in this bracket, you're going to take 0.25 times that. That'll be your change in tax. Right? Yeah.
When you say this bracket, you don't need to specify. You don't need to write out 3 or 4.
Well, the bracket is the 25% bracket.
Yeah. So you'll know, like, on the paper now that we're referring to that specific bracket.
I ran out of room. So yeah, if you want to put in the bracket, the bracket from 34,000 to 82.4 or something, yeah, it's probably better to specify what that was. Yeah. Okay, next one. The amount of tax owed on dollars earned at the 25% rate, or earned on dollars that you, the amount of tax owed on the dollars earned above 34,000. So what is this in terms of X and Y? Delta Y. It's a change, since 34,000 is your change in tax due. Change in tax due. Okay, tax of 34,000. That's the total tax due for the first 34,000 earned. So everything from before. What is this in terms of X and Y? Initial Y, old Y, right? Starting Y, starting value Y, or old Y, or initial Y, right? So then add it all together. You're adding together the tax due on the first 34,000 plus the additional amount of tax in this bracket. What does it equal?
Your tax.
Yeah, this is the total tax owed on all X dollars earned. This is your total tax. There are different ways to word this, okay? Different ways to word this, but the idea still has to be precise, okay? In all the details.
So the equation does the whole taxes on that specific rate plus whatever was due before, but when you break it down in terms of just 0.25 x minus 34,000, that's looking at just the amount owed after 34,000.
Earned in this rate or after 34,000. So then you add that to everything you owed before, and you get all your taxes there due. It was the same question you had after class. The amount, that height from before, plus the additional height in the top half of the jacuzzi. Yeah, it's the same thing. Yeah.
So if you were to word that last portion of it as the total taxes due for taxable income between $34,100 and $2,400.
Yeah, but it's a particular value for whatever X is. So it's not a range. This doesn't give you a range of numbers. You put in a taxable income, it gives you the tax due. Does that make sense? So it's true for that range, but it's a single value given a value of X, your tax. Does that make sense? Yeah. Okay. Questions on this? Okay, so here we've got, I showed you an image earlier where you had a quantity function on the right, and then looking at that as a piecewise linear function, and then looking at the rate of change on the left. So I want you, if you go to Blackboard announcements, there's a list of questions regarding this animation that you're going to take a few minutes to discuss with your neighbor, okay? So Blackboard announcements, I think it's 8 questions. Where can you see Sarah's taxable income growing? Where do you look in this animation to see taxable income growing? X-axis. Which graph? Both graphs show her taxable income growing. Both graphs. That's what the input into both functions was. Taxable income. Okay? What does the current value of her taxable income mean when that amount is continually changing? What would we mean by the current value of her taxable income? So it's kind of like we have to come along here and say right. Boom. It's kind of like we have to pause, right? If we can pause the growth of her income, then we get a current value of her taxable income. All right. So we need, like we think of the taxable income growing, but then we think we can pause it anywhere we want, and then analyze the given situation. So that's what we'll mean by the current value of X, or the current value of income. If we think of X increasing, then we think of pausing it at a specific value of X. Okay? So where can you see her marginal tax rate for the current value? So now I've paused it at, this looks like 43,000. 43,000. So where can you see her tax rate? Left graph. What about the left graph?
Yeah.
The Y value, right? The Y value on the left graph. Okay? And where can you see the amount of tax that she owes? This is the right graph. Get the output of the right graph, the y-axis, the total amount of tax that she owes. Okay? What does a point on the right-hand graph represent? So right there, what does that point represent? I heard over here, how much tax she owes to a corresponding income. That's a good way to say it. There are many ways, but this is a good way. It's two corresponding values of the corresponding values of two quantities. In this case, the taxable income of 43,000, and whatever that tax is, we could calculate it, but we can represent it as tax of 43K. K stands for 1,000. So we could represent that point that way. But points on graphs, right? In the types of graphs we're working with, mean two corresponding values of two quantities taken together. What about the left-hand graph then? Over here on the left-hand graph, what does that point represent? It represents tax rate
At a given.
at a given income. Same income now, 43,000. We know the value of this one. What is the value of, what's the Y value for this one? 0.25 in the third bracket, right? So 43K and 0.25. So that, what's that?
Which is also tax rate of it.
Right, if you want to represent it with function notation, it'd be tax rate of 43K. That's right. But we know this number, so I can put that number down. That's right. Why does the left-hand graph jump discontinuously? So we get this level, and we get a jump. And then we get a level, and we get a jump. Yeah. Right, so we have a constant rate, then suddenly we come to how many dollars? We come to the next dollar, and suddenly the rate is a higher constant rate. Until we get to the end of the bracket, we earn the next dollar at the break point of the bracket, and suddenly we owe at a higher rate. Okay? And so therefore that's why we get these changes in slope. We know the slope is the constant rate of change. So if we get a jump in the constant rate, we're going to get a abrupt change in slope on the quantity, in this case tax due. Okay? In what way does Sarah's tax due accumulate? How is this reflected in the graphs? So moving on to Module 3, this is the theme of Module 3, is what we're going to talk about, accumulation. So in what way does her tax due accumulate? So on January 1st, she gets home from work. She's worked on January 1st. Didn't get a holiday. It's too bad. It's a sad story, but she worked on January 1st. And does she pay, after that first day, does she owe the taxes that she would have to owe for the whole year after that first day? How much tax does she owe? Yeah, so she's going to earn taxes throughout the year as she earns money. Her tax due is going to accumulate a little bit at a time. Okay? So looking over here, say here we are at 43,000, and say this is on August 1st or something. So by August 1st, Sarah's earned 43,000. She's going to make a little bit more. Say she's going to work some fraction of an hour, and she's going to make 20 cents, right? So for some little amount of time, she'll make 20 cents. How can I show that on the graph right here, making 20 cents more of taxable income? Go to the right, right? And what symbols would we use for that? That'd be a delta x. So what did I say, 20 cents?
Yeah.
Delta x of 0.2. Right, 20 cents. So maybe this is she walked to get a cup of coffee, walked back to her desk, and in that time she made 20 cents in her overall of her salary. Okay? And what tax bracket are we in right now? What is the tax rate here? 0.25. So what amount of tax did she incur when she made that 20 cents of her salary? What amount of tax?
25%.
How does that relate to what we've been learning? That question, how does it relate to what we've been learning? If I'm asking about the tax, the additional amount of tax owed on this little increase in her taxable income, we would calculate that by? Constant rate of change, delta y. So we're saying the change in her overall tax is going to be, what's K? The constant rate of change times the little bit of income that she made. And that's going to be represented by some little delta y. So what is that? 0.05? 1/4 of 2.20 cents. So in that, when she made that 20 cents of her income, she just accumulated a little more tax, 5 cents more of tax. 1/4 of the amount that she made. So we can look at this tax then in two different ways. This tax on 43,000, There's two different ways to kind of get that or view that. We can think of that as, well, she's made $43,000 this year. And so if we put $43,000 into the tax function, it cranks out just the lump sum amount of tax that she owes so far. Okay, that's valid. But there's another way to think of this. We can think of it as a little bit of tax on the first 20 cents that she made on January 1st. Then a little bit more tax on the next 20 cents that she made. All right, how long is this going to take me to get to 43,000?
You're never going to get
there. Okay, so call it N. So there's some little bits of tax added together that get the entire amount of tax that she would owe on 43,000 by looking at a little bit of income that she earned and the resulting tax. The next little bit of income that she earned and the resulting tax. The next little income that she earned and the resulting tax. Each one of those could be calculated by, how could we calculate each one of those? No, delta y equals? So for this first, please stay with me. So this first 20 cents that she made, that's my delta x. What was the rate that she paid on that? 0.1, right? That's the first bracket. So once she got up to whatever this amount is, I don't remember what it was, 8,000 something, then that rate would change. So the delta x would still be 20 cents every time, but now she'd be paying at the higher rate. So your delta y should be calculated with a 0.15. And so we'd have this very long list. So it's another way to think about how the tax on 43,000 came about. Earned a little bit of income, so calculate the tax on that first little bit of income. The next little bit of income, calculate the tax on that, and then just add them all up. Add them all up. Okay? So two ways to think about the total tax due on 43,000. Okay, so this idea of accumulation, bit by bit by bit, huge theme that we're going to be going after in the next month. Cards.